This time we decided to make the video briefer, packing more information into a shorter time. We will have a look at the basics of TcoTask. TcoTask is a basic coordination block that aims to tame the wild cyclic execution of the PLC. This time, we cover just basics. In some future video, we will dive deeper. If you want to learn more about TcoTask, you can look at the documentation at docs.tcopengroup.org. I created a copy of our previous example and modified it a bit. So let's have a brief look at what has changed. First, I moved most of the code from the view model and moved it to app.xaml.cs. The constructor of the application looks pretty much the same as the constructor of the view model. What I have changed is the way we create the twin connector. We create the connector differently at design time and at application time. The design time connector does not connect to the PLC, making the XAML designer more performant. Let's have a look at the changes in the UI. I have split the window into three parts. First, we have the diagnostics view that we are already familiar with. We have the dynamic object tree view to observe and manipulate the PLC objects. Here we have just a list of I/O signals. Those prefixed with I are inputs and with Q are outputs. Let me briefly explain how this dynamic tree works, as we will use it a lot throughout this session and following sessions. We can here select any object from the PLC and ask the instant renderer a view for that object. We can choose the type of view from this combo box. Display and control views create the presentation down to the level of primitive types. Service provides user control for manual operations with the objects, and base will render a basic generic view of the object. Display and control will always render some representation of the object. The other presentation types will render something only when there is a user control created for that given type of presentation. Let's now have a look at the PLC program. I just cleaned up some code from the previous example that we won't need today. So, here we have a piston and simple state controlled by this case statement. When we run this PLC program, this sequence will start immediately. What if we want to start the execution of the sequence on demand? In order to organize chunks of code into action, TcOpen implements something called TcoTask. TcoTask is not to be confused with PLC task. Let's declare an instance of TcoTask that will execute this simple case statement in a controlled way. Let's call it simple task. Now let's close the simple state controller between if and if, where the condition for entering the if statement will be simple task.execute. Now the simple task will wait out until something or somebody invokes it, and will run the logic present in the body of this if statement. We can invoke the execution of the TcoTask from the PLC program or HMI. We will set the breakpoint at the line where we invoked the task and in the if statement. And we trigger the invoke method. We hit the invoke, and when we move forward in the program, we see that we are running inside the if statement. When we look at the status of the task, we can see that it changed from ready to busy. Let's just go over the states of the case statement. At this point, the case statement will run in circles, because at the last step we just return the state variable to 0. But what if we want the task to finish at the last step? In that case, we call the doneWhen method. We just pass true as the parameter. In this way, we end the execution of the task at state 20 of the case statement. And so the breakpoint here won't get hit. Let's create now something more complex with more tasks. We will have 2-axis pneumatic manipulator with horizontal cylinder, vertical cylinder and a gripper. We will have ground position task that will bring the manipulator to initial position. Then we'll have an automatic task that will move a thingy from one position to another. Then we will have a service task that will allow manual control of the cylinders. Let's see what we get in the HMI. I will select service-base presentation type. That just means render service view. If you don't find the service view, give me base view. If you have it. If you have neither, let it be. So now we have here the manual controls for the cylinders that are disabled. Then we have buttons that will execute the task, so let's give it a try. The ground mode seems finished properly. Automate task start, and we will try to abort it. That seems to work. Service task will enable the manual control of the components. Let's say that we want to allow the automate task to start only when the ground task is done. We can do that just like this. We won't be able to execute the automate mode until ground task is properly executed and done. We also want to reset the automate and ground task when we enter service mode. And we want to abort the service mode once we enter ground task. We can also force the task to enter error state. So let's say when the task lasts more than 5 seconds, enter error state. Now we can restore the task just like this. You may notice that the methods we use to control cylinder are somewhat related to the task. Your guess would be absolutely correct. The component cylinder uses the tasks internally. We can execute and wait for the completion, as we do here. We could also check that the task is busy or in error state. We can execute the task asynchronously and wait for the completion at some point later. This much about TcoTask this time. I will push the code to GitHub, and you will find the link below. Thank you for watching.